Okay, so we can apply our understanding of lenses to the human eye. We need to start off by actually being able to label the parts of the eye. Nice easy marks if they ask you this one. So here's the eye. The light comes first of all through the front of your eye. That's called the cornea. It carries on. It has to go through the pupil, which people think is a part of the eye, but it's really just a hole. It's a hole in the coloured bit of your eye, the iris. When it's gone through that hole, it gets bent by the lens, a convex lens in your eye. And the crucial thing about an eye is that we're not changing this distance between here and here. Your eyeball can't change its length to focus. So what has to happen is the shape of the lens changes. This is done by a muscle called a ciliary muscle. And to connect the muscle to the lens, there are some clever ligaments called the suspensory ligaments, which can change shape to change the shape of the lens. Once the light's come through the lens, we need to somehow sense it. That's done by the cells on the back of your eye here on the retina, and then that signal goes down the optic nerve off to your brain. Okay, notice that the image will be upside down because this is like a camera, and your brain has to do the turning around to make the image turn out the right way up. Okay, we need to just show you simply how the light is focused. Two different diagrams. If the light is coming from a distant object, that means it's coming pretty much parallel. Some of the focusing is done by the cornea because your eye is curved on the front. But this is going to make the light almost meet at the retina, so the lens is fairly thin, doesn't have to work too hard. So the light focuses on the retina. As long as the light focuses on the retina, you're going to get a nice sharp image. But if the object is much closer, this is a bit too close, but to make the diagram clear, we've got an object that's nice and close. The light is spreading out much more, so your lens has got to work much harder. So the way that your eye does that is to make this lens get much fatter, and it works much harder and focuses the light again on the retina. So far so good. If you've got perfect vision, you can see distant objects and you can see down to your near point, which should be about 25 centimeters away from your eye. However, as people get older, or sometimes for other reasons, your vision is not as good as it might be. Sometimes the eyeball isn't the right length, sometimes your lens just isn't the right shape. And we need to be able to correct that with glasses. So for short sight, that means you can't see things that are a long way away, distant objects. The reason is that when you focus the light, it focuses in front of the retina. Okay, this happens because you can't make the lens go thin enough. Okay, so the solution, if the lens won't go thin enough, is to put a concave lens in front of it, which acts the opposite way to the convex lens. So you put a concave lens here, the light goes through there, that makes it spread slightly further apart as if it was coming from a closer object. That then goes through the lens and focuses on the retina. Okay, the other problem could be long sight. Okay, with long sight it means you can't focus on things that are close because your lens isn't strong enough. So the lens is trying to make the light focus here, but actually it's focusing behind the retina. Okay, so this happens because you can't get the lens thick enough. The solution is therefore to give another lens which kind of gives it a helping hand. Okay, so we put a convex lens in the front. That helps it, so it does a little bit of the focusing before the light actually reaches your cornea, and then your lens is strong enough so you end up with a focused image on your retina. Okay, just a couple of details for those of you that have eye tests and have glasses and get told what the power of your lenses is, what your prescription is. Okay, this is how this works. The worse your sight is, so the further away your near point, the more powerful the lens you need to correct it. And the power of the lens is not measured with focal lengths like we normally do in physics. It's measured in things called diopters. And the shorter the focal length, the more powerful the lens. So if you've got a lens with a focal length of 0.5 meters, your prescription would be that the power of the lens would be 1 over the focal length, which is 1 over 0.5, which is plus 2D. They're always very careful to put plus 2D, okay, because for a lot of people you need a concave lens that's got a negative focal length, so you'll end up with minus 2D. Okay, so if you're short-sighted, you'll get a negative power of lens to correct your sight. Some people have lenses which have to be very powerful. That would make them very thick, and in order to make that a little bit less of a problem, what you can do is you can make the lenses out of a very high refractive index material, and that means you can make the lens much thinner and still be able to do the same job.